let's discuss null and alternative hypotheses and p-values. Now, the null hypothesis, denoted H sub 0, is the hypothesis that a population parameter is equal to some value called the null value. The null value is denoted P sub 0 for proportions and mu sub 0 for means. So we're going to look at a few claims here about population proportions. This one is from Fox News. It's a Fox News poll. And it says a majority of 52% want government assistance, which is up from 44% in 2021. The 8-point increase comes mostly from a 19-point jump, blah, blah, blah. Okay, so the claim that's being made there is a claim about a population proportion of people who want government assistance. So the null hypothesis in that case would be that that proportion of people that want government assistance, which we call P null, P sub 0, is equal to 52% or 0.52. That's what this claim that is being made by a Fox News poll is. Washington, D.C., this is a Gallup poll. It says, according to a 2018 Gallup poll, 5% of U.S. adults consider themselves vegan. So in this case, a claim is being made about the proportion of U.S. adults that consider themselves not vegan, but vegetarian. Vegetarian, those are not the same thing. So the null hypothesis in this case would be that the proportion who consider themselves vegetarian, P null, is equal to 0.05 or 5%. So that would be the null hypothesis. And then this last one, this is another Gallup poll. A majority, or 62% of Americans, say trans athletes should only be allowed to play on sports teams that correspond to their birth gender, while 34% say that they should be able to play on sports teams that match their gender identity. So let's focus on this 62%, the first one we came across. And the claim that's being made there, the null hypothesis, would be that the proportion here, the null proportion, would be equal to 62% or 0.62. Okay, so that is the way that we construct null hypothesis. There's a claim made. The null hypothesis will always say that the proportion or the mean or the standard deviation is equal to the value that's being made by the claim. So whatever the claim that is being made, the null hypothesis says that the population parameter is equal to that number. All right, so the null hypothesis says it's equal to some value. Once you know what the null hypothesis is, this actually implies that the sampling distribution is centered at that null value. Because if that null value is the actual population parameter, for instance, if it's the actual population proportion, then we know that sampling distributions are centered at the population proportion. So if the null proportion, or the proportion from the null hypothesis, is actually the true population proportion, it will actually be the center of the sampling distribution. And you'll have a sampling distribution that has the null proportion as its mean and this as its standard error. So the standard deviation will be the square root of the null proportion times 1 minus the null proportion over n. This will be the actual sampling distribution if the null hypothesis is true. Okay? So there's an alternative to the null hypothesis that we have to set up, because even though we're constructing the sampling distribution under the assumption that the null hypothesis is true, we don't actually know if it's true. We're going to go out and we're going to collect a sample, and the sample is either going to support the null hypothesis or some alternative to the null hypothesis called an alternative hypothesis. The alternative hypothesis, denoted H sub A, is the hypothesis that the population parameter is somehow different from the stated null hypothesis population parameter. So the alternative is the alternative to the null. So if the null is that the population proportion is equal to that null proportion, the alternative set is different in some way. So there's a couple ways that could be. For instance, we could think that the null proportion is not correct and the actual population proportion is less than the null proportion. If we think that the actual population proportion is less than the null proportion, we are looking at what's called the left tail test. We're hoping that our test statistic p hat that we get from collecting a sample is smaller than our null hypothesis proportion, the null proportion. Because if it's not smaller, then our idea that the proportion is actually less than the null proportion is probably not true. But if we do have a p hat from a sample proportion that is smaller, we can take the test by finding the area to the left of that p-value in the sampling distribution. Because here's what it is. We're assuming that this is true, but this sample is something that happened in reality. So what we're saying is, if this is actually true, I want to find a probability of having a value at least as extreme as what I observed in my sample, at least as small as the one I found in my sample. So I'm going to be looking, in a case of a left tail test, for the area to the left of my test statistic, or to the left of my sample statistic in this case. So that's what a left tail test is. We have the null distribution, which is a sampling distribution that has the null parameter at its center. And if we're doing a left tail test, we're going to be looking at the area to the left of a population or of a sample statistic. Usually we're going to turn the sample statistic into a test statistic so we can calculate that area. All right, there's another case. So this would be the case where we don't think that the 52% population parameter is correct. We think it's less. We think it's less than that. And because we think it's less, we're doing a left tail test. What about the case where we think it's more? It says here, Gallup says that 5% of Americans consider themselves vegetarian. What if we think that it's more? We are some vegetarian lobbying group and we think there's got to be more than 5%. So we go out and we collect a sample. Well, hopefully our sample has a proportion in the sample higher than 5%. Otherwise, it doesn't make any sense to run this test. But because we think that the proportion is actually higher, we're running a right tail test. We want to know what's the probability of getting a sample at least as high as ours or higher. All right, and that would be a right tail test when we think it's actually larger than what was stated by the null hypothesis. And the last kind of test that we could do is when we just think it's different. We don't know if it's larger or smaller. We just want to know if it's different. So in that case, the test statistic, we're actually looking to see if we get a value either that extremely large or extremely small on the other side. So if the test statistic is to the left of the null proportion, then we're going to, or if the sample statistic, I should say, if the sample statistic is to the left of the null proportion, then we're going to take the p-value or the probability to be twice the area to the left of that sample proportion. On the other hand, if the sample proportion is larger than the null proportion, then the p-value would be twice the area to the right of that sample proportion. So we have, once again, 3 different kinds of alternative hypothesis. If we think that the actual population parameter is less than the null proportion, then we were doing a left tail test. If we think the actual population proportion is greater than the null proportion, then we're doing a right tail test. And if we just think it's different than the null proportion, then we're doing a two-tailed test, and the p-value is actually twice the area to the right of, if it's on the right of the null proportion, or to the left if it's on the left of the null proportion. And that's how we're going to approach these hypothesis tests.